It's live.
All right, cool. So welcome everybody to our second day of learning how to use Git. Today we're going to work on using Git for collaboration. So last week we showed how to use Git essentially just by yourself. You can version control your own work on your own computer and sort of use this thing called GitHub to treat it as a remote backup. Now today, what we're going to do is start paving the road for collaborating with other people. So I'm going to start off with setting up the repository for today, which will also be a refresher for last week. So if we're all in our terminal, I'm assuming if everyone doesn't say anything, the font size is okay. So you can see I'm in my home directory and in a folder called Git. This is something that I do, so I know that everything in this folder is something that's tracked, and so all my Git projects are not scattered all over my computer. If you have a very specific folder structure already, what you can do is create a shortcut into the Git folder, so at least you know everything in here. You can point to somewhere else. So last week I had a folder named 2016-04-06 Git training Git intro. So for this week, I'm going to create a folder. Instead of the 6th, today is the 13th. And I'll just call this Git intermediate. And when I'm done with that, I'll just go into this folder. And so a lot of this stuff that I'm doing right now is going to be a refresher, again, a refresher from last week, but this way we all start clean, so you don't have to worry about if you deleted the folder from last week or if you're just in today for the first time. So what we can do is let's initialize this repository using git init. And we can create a README. So we can use a program called Nano to create a README. I'm going to be using Markdown, so I'm going to just call it .md. I'm going to say git training, dib training part 2. All right. So I created a new file. If I look at git status, you can see that I have an untracked file called readme.md, and I can add this file, and I can make this commit. And, right? Okay. And then last week, I also showed you guys something called GitHub. So let's create a repository on GitHub and set up the push-pull system so we can essentially treat this as a backup. So I'm going to open up GitHub. I should be logged in. I have a button called New Repository. If you don't see this button here, you might be on, yes, not this screen. You will be on something like this, in which case you can click on Repositories and click on New. And it's going to ask me for a repository name, so I'm going to go back here and just call it the same name as the folder I created. And dib training, dib git training part 2. And I can just leave the things on the bottom blank. And now that I created a repository on GitHub, we can use this remote command to add this GitHub as a place to save our work. I'm going to copy essentially this line here, and I'm going to paste it. For you guys, make sure you probably need the HTTPS link up here and not SSH. Again, you can set up something called SSH, but I think it's out of the scope for this talk. But for the most part, if you don't know what SSH is, chances are you need the HTTPS link. So make sure you have HTTPS selected, and then copy this line. And if you want to check that everything is doing well, you can run this command called git remote-v, and you should see origin and that link that was provided for you on GitHub. And when you're done with that, you can do git push origin master, and that will upload everything on your local computer back up to GitHub. So I know I went through that extremely quickly, so let me know when everybody has the README on their local computer and the repository set up on GitHub. So if you refresh the page, you'll know that you've done it correctly when your README file gets rendered underneath, and it should be just that one folder, one file. So let me, and since people are waiting, I guess just for future purposes that I totally forgot to mention, this is part of a workshop series run by UC Davis, and it's part of their Data of Intensive Biology series, and you can read more about it here, and they have a whole bunch of other workshops that are all related to doing computational things. And Git is just one of the things that computational people work with. For questions, please use the the chat box in the Etherpad, and if the YouTube link is also on the top of the Etherpad, so it's definitely a good entry point to see where everything is. And yeah, so I'm just gonna wait here until everyone's caught up, and just as a prompt, create a new folder in Git. Create a new folder. As a Git repo, create a file, add to it, and commit the file. Create a repo in GitHub. Add the GitHub repo as a remote. Push your local. So those are roughly the 7 steps that I just went through. So I'll just look at the Etherpad, and I guess that's how I'll know when everyone's ready. Is there a significant difference between using git push-u versus git push? There is a difference, and what the -u does is it sets a default. So if you run git push-u origin master, the next time you just type git push, it'll automatically know that you're pushing to origin and master. So that's all that the -u does. Otherwise, you're always going to have to specify the where you're pushing to and the what you're pushing to. I like to be a little bit more explicit, and you'll see why when we go on in this talk or in this tutorial, where if you start setting defaults and you create these things called branches, which we're going to be covering, you sort of run the risk of just by sheer muscle memory type commands that you don't completely mean. So that's the main reason why I stopped using the -u command. So I guess someone from each of the respective sites just give a +1 in the chat when your place is ready or something. So I had a question earlier here about what can you use Git for? And I know like a lot of the examples I've been using, everything was done in a terminal, but it doesn't have to be a file that you can only edit in the terminal. For example, you can edit a regular Word document, save the Word document as you normally do, and then you can drop down to Git and think of it as think of it as a backup for the Word document that you just saved. And then you can use GitHub to create yet another backup of the Word document that you saved. So all Git really does is track changes, something that's built into Word, but it's a little more flexible. It's not just within Word. You can track, Python scripts, you can track Word documents, you can track Excel sheets, you can track PDF files or images like PNGs, JPEGs, SVG elements. So anything that's a file on your computer, you can use Git to track. The only thing about Git is don't track like your 6 gig CSV file. That's something that you probably don't really need to be tracked. Chances are that 6 gig CSV file is going to be the basis for your rest of your analysis, so there's no reason why you should track your original data set, because all the changes you're making should be captured in scripts. So it is very good data practice to not edit the original data file that you're working with and just do everything with scripts. And then with scripts, since they're really small and they're one-off, you can track your scripts. Your scripts can create intermediate output that you need. And you don't even need to track those intermediate outputs because you can always recreate them using the scripts. So if you need a place to store your data, I won't go into it in this workshop, but there is something called Git large file storage, I think. Yeah. So this is one way you can store Git track really large files. I personally haven't used it yet, but that is available. In terms of pushing data to GitHub, I definitely know for Bitbucket your repository can't be more than 2 gigabytes. Git probably has something similar, but if you need just like an open place to store data for the public, Amazon does have a system where if you're okay with this being a public data set, they will host it for you for free. If it's not going to be an open data set, chances are you're hosting it in-house in your own servers, in which case, you could just have a separate network drive that just stores your data, and your scripts communicate with that data just through, file directories, and you can just track your scripts that way. So you don't, with working with very large data sets, you don't have to have Git tracking them. But there are ways like using Git large file storage.
Is it free of charge? Does Git store file storage?
I'm not sure how the Git large file storage thing works. Again, Git is just a tracking tool. So this is tracking data sets from Git. That's not the same as pushing it to GitHub. GitHub is just somewhere on the internet that stores, think of it as like another hard drive that you can connect to, or it's the cloud, or it's Dropbox. It's just somewhere where you can take something on your local computer and sync it to something that's not your local computer. So Git large file storage is just a way for Git to track large data sets, because chances are, if you do make a change to a very large data set, it's going to be a very big change, and you don't want that cluttering your actual scripts. So yeah, Git large file storage is separate from GitHub, and I don't know the details about how GitHub works with Git large file storage. So, all right, cool. So, moving on. So everything that you did. Where's that picture? So if you remember, this picture should look somewhat familiar. So again, we make a series of commits. By default, this series of commits has a name called master. Head essentially just points to where you are in this series of commits. So you can think of it as every time you make a commit, you saved a snapshot of your folder. And now you can, head just points to which snapshot you're looking at. So you can go back to the very first time your project started to the most recent time and any point in between. Checkout is the way where you can take head and move it around. We created this thing on GitHub. By default, anything that's not the place where you type git and init is going to be called a remote. By default, the remote that you're working with is going to be called origin. And origin is essentially just mimics everything on your local computer. So you have a series of commits, and by that series of commits, you have by default something called, it's named master. And the way you communicate between these two is push and pull. So what we just did was we just pushed all of our changes to GitHub. And just so we're on the same page from where we left off last time, I showed you making a change on GitHub and a change on your local computer. Or actually, I need a few more lines. So we can use GitHub to change a file. We can use the text editor built in GitHub. So I can click the README file that you just saw. I can click the pencil. And I can use GitHub to make an edit. This is useful for you don't have your computer on you, or you just don't want to deal with the whole Git infrastructure, and it's just like a small typo. You can use the pencil. So this is an edit from GitHub. And I think it'll be useful if we make this a few more lines. So today, we will discuss, what are we going to cover today? Conflicts. And conflicts, branches, merging, pull requests, forks, etc. Right, so I know that a lot of those words are just words that don't mean too much right now, but this is just me trying to come up with a multi-line example, so you guys can have anything. You type whatever you want. And then again, because this is Git, everything that you do has to have a commit, has to be committed, and has to be recorded. So even if you're on the GitHub editor, you have to make a commit message. So this is talk about what we plan to cover today. And this. And I can make this change on GitHub. And you can see after I do that change on GitHub, it'll render on the GitHub interface. If I go back to my local computer, should not have that. If I look at the README, you can see it doesn't have those changes. And if you remember from that diagram, pushing was taking our local computer to our remote. And now we have a change on GitHub that we want to bring back to our local computer, so that is a pull. So we're going to run the git pull command. And git pull has the same syntax as git push. The first thing is where are we pulling from. We're pulling from origin. And the thing we're pulling is master. If you're using the HTTPS link, I believe it'll ask you for a username and password. So type your GitHub username, hit enter. It'll ask you for a password. When you start typing your password, it won't actually give you any visual prompt that you're typing anything. And that, again, that's really just a Linux way of being secure so no one can start guessing your password based on the number of characters. So type your password and hit enter. If you type it wrong, it'll reprompt you for the whole process, so don't worry. And when you're done, it'll say something along these lines where you're making an update, you're getting it from the master branch. There's this thing called fast forward, which I'll cover in a little bit. I edited the README file, and I added 3 lines, and it just prompts us to do that. So let me check on the Etherpad to make sure everyone is caught up there. So that's, I guess, okay, cool. So that is a 15-minute recap of last week's 3 hours, right? So now, what happens? Actually, it's almost a 15-minute recap, but I'll do this example now. So what happens if last week we ended with making a change in 2 totally different parts of this file, and Git is smart enough to know that if you make a change, for example, in the beginning of a file on GitHub, and if you make a change at the end of a file on your local computer, if you try to make a push, it's going to say, I can't just push this to GitHub. You have to sync all your changes. And when you make that sync, it will know that those 2 changes are not conflicting. So I realize I just said a bunch of words, so I should probably just demonstrate this. So I'm going to say, instead of part 2, I'm going to give it a number 2, and that'll be my change on GitHub. So GitHub change 2. So that'll be my GitHub change, and then on my local computer, I'll just make this a markdown list, for example. So these are 2 totally different changes. An example of something that follows this kind of workflow is, just to lead into collaborating, is if you're working on a paper with people, you can just say, hey, don't edit below this line, or you just have the introduction, don't change anything below the introduction. You can have people work on the introduction, you can work on methods, someone else can work on results, and someone else can work on discussion. And because you're editing the file in totally different places, that's sort of, Git will be able to manage that. So I made this change on my local computer. If I look at Git status, I'm going to say, hey, instead of new file, it's going to say a change not staged for commit. So this is, again, a file that I've told Git to track. And this is a file that's changed. And so we can use git diff to see, hey, what is the difference? So you can see I just turned this one line that turned red, and that red line became the series of green lines. And that looks like a change I want. And so we can say, oops, git add. We can add the README file, and we can make a commit. Make list into markdown list. There we go. Right, and so now just to continue through the example that I talked about, we made a change on our computer, and let's say we want to sync this up with GitHub. We're going to say git push origin master, and then GitHub's going to reject this because the version on GitHub is totally different. No, it's not totally different. It's different from the version on our computer. And so it's going to say, hey, I want you as a human being to actually, make sure that you're okay with all the changes before you tell me to update. And Git gives us it tries to give us useful hints. It's going to say, you may want to first integrate the changes before pushing again, and you can integrate changes using this command called git pull. So let's run git pull origin master. And because it's running a poll and there was a change, it's going to say, hey, this was something different that happened. So anything that's different will have a commit. and this is the message why. This is why this message comes up. It's already filled out for you, saying that this is just merge branch master of this. So what you really can do is just save and quit this file. Don't worry about where this file is saved. Just save and quit the file. And then it's going to spit out this series of message, and it's going to say auto merging. So it's going to try to merge this file by itself without having you as the user intervene. And it's going to try its best. And in this case, because we edited the file in 2 different places, it's okay. It can figure that out. It's smart enough to at least know that. And it's going to say, hey, you just made 1 addition, 1 deletion from this file. So 1 file change, I added a new line, and I deleted some lines. And now if I look at my README file, it's going to have the change on GitHub and keep the change on my local computer. If I run git status, it's going to say, I'm on branch master, there's nothing to commit, my working directory is clean. Meaning that all the changes that have happened, or any changes that I've made to this file, everything's been committed. And since I have a commit, Git is ready. Like, there's nothing else to do. Everything that I know that's changed has been accounted for. And since I know that's the case, I can push this up to GitHub. Now, if I view the README file on GitHub, again, I still have the change from when I edited the file on GitHub, but now it's incorporating the change on my local computer. All right. So that is where we left off last week, but now the next obvious question is, what happens if you edit the same file within the same file, you edit the same line, or you edit something in the same place? This is going to happen. You can be collaborating with people, and you say, hey, don't change anything after the introduction, but there's this blaring typo or something in the method section that some people just can't control, and they make a change there, but that's the same place you've made a change, or you caught that example or something, and you both edited the same place. So we can fix this by I am going to, what is a nice example? All right, I know. So I'm going to edit this file on GitHub, and whoops, not raw. Whoops. So I'm going to click the pencil on GitHub. Again, raw is just looking at the actual raw file. So I'm going to hit the pencil, and I am going to say GitHub starts with a capital G, and so I'm going to make that typo. I'm going to fix that. And I'm going to say fix typo GitHub to GitHub on GitHub. All right. So that's my change on GitHub. And again, I'm going to do the same thing, except now on my local computer, I'm going to edit that same line. In this case, I'm going to show you what happens if you edit that word GitHub or anything else on that line. So, nano readme. Again, I'm using nano. You guys could use whatever text editor you want. Sublime, Notepad++, regular Notepad, TextMate, etc. It really doesn't matter. And so let's see if I remember my markdown notation correctly. It should look like, I'm going to turn GitHub into a link, which means putting square brackets around the word, and then in round brackets right after it, the actual link. Oops, oops. And let's just fix this v2. So I'm going to save this file as that. So this is an edit from GitHub, and I'm going to turn this into a link. So if I look at git status, this shouldn't be surprising. I just made a change. So let's add this. And again, you can use the period to add everything from where you are down. So I'm going to add this file. and write a commit, GitHub to link and fix local. Right, so I made a local change. This is exactly the same thing that I did before, but now if we run git push origin master, you get the same problem, right? Because the version on our local computer is different from the version on GitHub. So this is not surprising. We expected this, or maybe you didn't expect this, but this is an error, a series of error messages that hopefully over time or by now, you won't get really nervous. And it's going to say, hey, let's integrate our changes. So let's run git pull origin master. And so now this looks a little bit different. It's going to say auto merging, and then the next line is going to say conflict. There's a merge conflict in this file that we have called readme.md. The automatic merge failed, fix the conflicts, and then commit the results. So if hopefully I can scroll back far enough. Yes. So the previous message said auto merging, and the merge was actually made by a recursive strategy, and then it showed you some histogram and details about what happened. In this case, it's going to say, hey, I couldn't do this. And it makes sense. We made a change in 2 different places. I really don't know of any algorithm that I can tell a computer to guess which change I actually meant. Right? You might think, hey, just base it off the timestamp. You know, that's not a universal solution, right? So, you know, just to be safe, let you as the person who is working with this, you deal with it. Again, if you work with a very large project, chances are you might have edits in multiple files. Some of the files might automatically merge, and they'll be fine. But this will always, if you ever get lost, like, hey, I just have a conflict, how do I know which files to even start looking? This line right here, if you have multiple files, it'll list them. But the file to look in is going to be in readme.md. That's where you look for the file that you have. Again, this is a really simple case. There's only one file we can look at. But again, projects are not just one file. So if you ever get a conflict and you're just like, oh my God, there's like 50 files here. How do I even know which ones have a conflict? Git is actually pretty useful. So don't get too scared about the amount of text it's printing out to the screen. So let me think. I'm going to use Nano to open this file because we're going to be editing this file. If you are comfortable with the GUI, it might be better to use that in this example. Just because we're going to be deleting lines, and terminal deleting might be a little weird for people. So I can open this README file, and you can see that this file actually changed. Git added like a whole bunch of weird words to our file, and essentially this is saying, hey, this is where the conflict is. So Git knows that there was a conflict here, and it's pointing it out to you, hey, fix this. I couldn't resolve this issue. And this is a really big file, and you can't, you know, the reason for this kind of notation is you can do a search and search for like 5 less than symbols, and it'll just jump. And then that's how you'll find the beginning or end of a conflict. So it's going to say a bunch of less than symbols, head, and head refers to the version on your computer. And then it's going to be separated by a bunch of equal signs. And then everything from that equal sign to a bunch of greater than signs, that's, in our case, the version on GitHub that's conflicting, right? So this is a really simple example in which case we're just looking at one line. But if you edit like a function in Python or R or something, this might be the entire function being different or something along this line. And it's really, now it's your job, hey, I'm showing you the conflict, go fix it yourself. And so let's decide which version do we want to keep. I kind of like the version I have on my local computer just because, you know, I fixed the typo and I actually made it a link, and it just seems a little bit more helpful. And so how do we actually go about resolving this? You literally edit this file until it makes you happy. So if you're in Nano, you can scroll to the beginning of the line and use Control K, and it'll just cut that line. But essentially, you are editing this file until it makes you happy. So I don't want any of these lines, and this is the final thing that I want, right? So it's going to show you that conflict, and now it's up to you to go resolve it. And so after deleting all the lines that I don't want, again, I can even now make a change to this file. So period there, right? So however you want that conflict to be resolved, go ahead and resolve it. And so let's save this file, and we'll exit. If you look at Git status, it's going to say fix conflicts and run git commit. All right, cool. I fixed my conflicts, and I'm going to run git commit. And I can say fix conflicts. And it's going to say, hey, you can't just do that because I actually never added this file to my staging area. So let's add this file. And then it's going to say, okay, now you've added this file. Now let's use git commit to conclude the merge. It's like, okay, cool. So now let's write git commit fix conflicts. Conflict is really just one. Now if we run git status, it's going to say we're on branch master, nothing to commit, our working directory is clean. Great. And now if we run git push, all of the conflicting changes have been resolved. The version on our computer is essentially the version we want. And now if we go back up to GitHub and hit refresh, you can see GitHub is now a link, and there's a period. So that's how did I type that wrong? I probably typed whatever. The link is bad, but it's a link. So yeah, so that's how you deal with merge conflicts. So I'll pause for everyone to catch up on what I did or wait for questions. Do you have a question or anything?
Like in GitHub, can you only edit like a text document or script? Can you, I mean, just like what I mentioned before, can you just go ahead using Excel? It's local, right? If you use Excel, SPSS is local, right? But I mean, on GitHub, you cannot use all these. Right?
Yeah, so the question is, like, I've been using the pencil to edit a file in GitHub. Let's say I have like a Word doc on GitHub. Can I use the pencil to edit the Word document? I don't think so, because Word docs are like a binary format, and this is really just editing text files. So, you know, Markdown is cool in that it's really HTML and it'll render nicely, but the raw form of it is really just a plain text file. And so, you know, this is sort of like the big nudge on like, hey, make everything in your life a plain text file, because it's easier to work with. Yeah, I'm pretty sure. Yeah, that's definitely. I needed the https:// Yeah, I needed an actual proper link and not github.com. Maybe I'll fix that in the next part. So that's what we'll do. We'll fix that. Let me think on how I want to deal with this. Okay, cool. So now I'm going to go into talking about branches. And so let me find the picture. Actually, no, I don't want to talk about branches. I lied. Sorry. Do I want to talk about thinking. Okay. Actually, I'm going to just start the first round of collaboration with you guys. So the easiest way for you to collaborate with somebody, and this really works if you just have 1 or 2 people, is you can go to the settings panel on GitHub, and you can go to the collaborators, and you essentially just add someone as a collaborator. So hopefully, everyone who's watching or streaming, if you're streaming from home, I guess you can follow along. But hopefully everyone in Davis, pair up, find a buddy, because this is going to be your buddy for the next 3 hours. So what you're going to do is, find who's going to be the proper owner of a repository. So someone's going to be an owner, and someone's going to be a collaborator. And a collaborator meaning this is someone who's going to be contributing. And so you can, for the owner, you can add that person as a contributor. So I can add my teaching account as a contributor to this repository, right? Let's hope this works. And so by adding someone as a contributor, you're essentially saying, hey, I fully trust this person, and this person can make direct changes to this GitHub repository. So essentially you're saying that person is really just like another me. Just like how I've made local changes on my computer and I push-pull to GitHub, I'm essentially giving that other person push-pull access to my exact version on GitHub. That's what you're doing. Might be a little scary, but this is the simplest way to have a contributor. And it really works well if you're just dealing with one person or 2 people, because chances are it's easier to delegate tasks that way, so you won't have this constant conflicts. Just like how I was using GitHub, the pencil in GitHub to make changes, and also making changes on my local computer. You can now envision that the person I added as a collaborator is that person constantly making changes using the pencil on GitHub, right? So if you delegate your task properly, or if you're working on an analysis project, each person has their own script that they're changing. That's not going to be too much of an issue. The worst thing that could happen in that case is you're going to try to push something on GitHub, and it's going to say, hey, these are out of sync. You're going to have to run a pull before pushing again, right? But again, just like how I showed you, you do run the risk of having merge conflicts. And then by adding people as collaborators, the chances of having merge conflicts just increase. But let's show you how this works. Yes, your collaborator does also need to have a GitHub account. There's no way around that. And so I am going to need a different terminal. Is this terminal different enough from this? It is not visually different enough. Let's not make it on black. Let's make it on light yellow. So I'm just going to ask you guys, can you read that bright yellow text, this other terminal? Because that'll be... it's not a one-way add, so the person who owns a repository just adds the other person. So this is your project, and you're saying, hey, you can collaborate with me. So it's really just a one-way add in that regard. The other person, unless the other person has a totally separate project that they want to add you as a collaborator, you don't have to circle people around. Is there a white background? Okay. black on white. How do I turn the transparency off? There we go. All right, how's that? White background, transparency off. All right, cool. So I'm going to designate this white blob as the collaborator and this black blob as the person who's owning the repository. And so what did I do? I added that person as a collaborator. So what does life look like for you as a collaborator? I'm going to go into incognito mode so it doesn't. Chances are you will get an email saying that, hey, you've been added as a collaborator. So, I'm teaching. If it's the same password. Yes. And so, you as a collaborator, you should get a notification saying that, hey, this other person added me to this project, right? And so now as a collaborator, it's awesome. Like, I get to work on another project. And how do I go about adding this person to this project? Well, I click on the link that I've been added to as a collaborator. And so this is the original repository. This is the original owner. And you as a collaborator, it just means I can now have direct access to this project. And so you can find the HTTPS link right here, and you can copy this. So essentially you're saying, hey, I'm going to bring this repository down to my computer. Right? So we're going to click on HTTPS, we're going to select this and Control-C to copy the link, or you can click this button and it'll copy it to your clipboard. And so now, how do you actually start collaborating on this project? Where is my terminal? Don't tell me I closed it. Nope. Did I close it? Oh boy. Probably did. Sorry about that. Right. So, what am I going to do as a collaborator? I'm going to go to my Git folder, actually. In this case, since chances are you guys all have the same folder name, let's make another folder called collaborations, right? And now I'm going to go into collaborations. And now I'm going to run this command called git clone. And git clone is very similar to git init in that you really only type this command once. And what git clone does is it gets the link from Git from a remote, and it's going to clone, meaning it's going to download everything to your computer. And by everything, I mean the entire commit history. All of that is going to come down to your computer. So I'm going to run git clone, and I'm going to type in that link. And when you're done, when you're done, what should happen is that folder, meaning the name of that project on GitHub, is going to be a folder on your computer. And if we go into this folder, we can see that this is the exact same thing that we've been working on so far this morning or afternoon, depending on where you are. Right? So again, this computer, the black side is the original owner, and the white side is going to be someone that you've deemed, trustworthy and can collaborate with you. So I'm going to pause there to make sure that there are no questions on what I just did. So let me just show the history. I made a folder called Collaborations in Git, which is, you know, you can have subfolders. I know this is a completely clean folder. So, and then in there, but I ran the git clone command and put in the link from GitHub. And what that did is it created a folder with that same GitHub repository name, and I just went into it. And it will be exactly the same thing as the version on GitHub at the time of me typing git clone. So, any questions? Yeah, so I'll just wait until everyone's caught up from that point of view. Should probably move things over. Okay, cool. So now let's actually do some collaboration. And I'm going to make the easiest form of collaborating here where we're going to both put up different folders, right? So let's say me as person A, what I'm going to do is I'm going to create a file. Let's create a file called owner.txt. I'm going to say, I am the owner. I have the final. I should have the final say on what happens. Okay. I'm going to create that file called owner, and I'm going to look at git status, and nothing new here, right? This is just me working totally on my own. I'm going to say, I'm going to git add this, I'm going to commit this, and say I am the owner. Right? I'm not going to do any pushing or pulling yet, but, and let's say at the same time, your collaborator creates a file. I'm hoping I'm doing this correctly, but let's say your collaborator creates a file called .txt and say, I am the collaborator. Since I am I can do whatever I want. Okay. So my collaborator, he created a file, and from his point of view, this should be nothing different from what you've been learning. He can look at the git status. There's a new file. He can add, he or she, sorry. Your collaborator can add this file and commit and say, I am a collaborator. Right? And so, I don't know, someone pick someone to push first. Because again, the beauty about Git is once it's on your local computer, you can work independently from anyone else, right? So let's say my collaborator pushes first. So he's going to say, he or she, your collaborator, is going to say git push origin master, right? So before I actually show you that, the remote is going to be origin and that link, right? So when you run a git clone, this remote is automatically set up for you because it knows that you copied that link from a place, it knows where you got it from. And by default, that place where you cloned it down from is going to be called origin. Right? So we can run git push origin master. In this case, hey, look, HTTPS. So you definitely know what this is. And I think, you must verify your email address. Oh, interesting. Huh. I don't know where I put this. All right. So apparently I need to verify my email address. So I am going to have to do that. Hopefully you guys have that problem too. Oh, I don't remember this password. Oh, please, last pass. Oh, worked. Okay. So any questions as I'm frantically trying to confirm my email address?
Dan, I presented my screen so your inbox is not on the internet.
Okay, cool, thanks. Although yeah.
You know, ready.
But it should be okay. There's nothing in this inbox other than a bunch of,
Okay.
Yeah, this is like my forum subscription inbox. So
All right.
it should be okay.
That then.
But how do I confirm my email address? Oh boy. Resend. Please verify. Yes, I am a human being. All right, email is verified. Let's try that one more time. I'm going to run git push origin master. And there we go. Okay, so email verification worked. Again, thank you, Git, for being helpful and giving me messages. And so if I go back to GitHub now and look at the repository, my collaborator straight up made a change to my repository. Right? It's a little scary that he made a change without even, potentially letting you know that your collaborator just straight up made a change. But that's okay because you added this person as a collaborator, and those are the risks of adding people as collaborators. But now, let's say on your end, as the owner, you're done with all your work and you're going to make a push. And we're going to see the same error message as we did before, right? Let me just run that again. This is the same error message we got when I used the pencil to edit something on GitHub. A change was on GitHub that's not on my local computer, and it's going to say, run git pull before pushing again. So this is what happens when you straight up add a collaborator to your repository, is that if it's really active, this is going to happen a lot. The version on your computer is going to be out of sync from the version on GitHub, but that's okay. Earlier today, I showed you how you can deal with this. So git pull origin master is going to say, hey, there was an actual change there, and we want to keep a record of that. That's fine. And it pulled down this collaborator text. So if I look at what's in here, I have the original owner text that I made, and the collaborator text came down. And now I can push origin master. Right? So before I used the pencil to edit the same file, you can create multiple files. So you can even have this problem even working with yourself. But now you can think of, now there's two of you, so now you have twice the number of problems or potential that this will happen. So back to GitHub, see what that looks like. Now the collaborator and owner, both those files are on GitHub. So that's the simplest way that you can collaborate. But it's a little, especially if you're working with code or even, reports or something. The beauty of GitHub is that it has a built-in way to do code review. So before anyone actually makes a change in here, someone has the potential to review it before it gets put in. So let's say, even though your collaborator is great, both of you should review each other's work before it becomes final, right? And so that will go into the realm of branching. So I'm going to first show you how you can work with branches on your own. And again, in this context, it'll carry over and it'll be exactly the same. And so we'll do simple branching, and then we'll take a break, and then we'll go into how you can do more advanced forms of collaboration with branches. So how do you create a branch, or what is a branch? Let's go over that. So I showed you that this linear series of commits by default is something called master. And all a branch is, you can think of it in a few ways. It is a branch from master, and you create a linear series of commits, right? So it's just something else that's not master. Another way you can think of it is a branch is really a series of commits that you want to give a name to. All right, so I've been working with readme.txt. We can have this, and let's say I want all the changes to owner.txt. I want that to have a special name. I want to group those changes together, and I create a branch for those changes. Right? So there's a few ways you can think about it. One of the biggest reasons why you even have something called branches is because you want master to be a state that works. So if you're working with code, master should be a version of your code that you can always jump back to and run your code again without having any problems. And then you create a branch. So let's say the software carpentry function example is I create a function that converts Kelvin to Fahrenheit, right? And so now if I am committing and it's on master, I can always jump back to the version where I have Kelvin and Fahrenheit. But let's say I want to add a bunch of other stuff, like Fahrenheit to Celsius and Celsius to Kelvin converters. Maybe I'm not that great at programming right now, and I don't want, let me try. I don't want my boss to come up to me and was like, hey, can you run that calculation again? I was like, I can't do that because I'm in the middle of doing this and nothing's working right now, right? So this gives me a point to say, hey, I'm working on this, that's fine, it's sort of temporary, but I can always jump back to where master was and just rerun that right away. So let me show you what that looks like in practice. So you can do this on your local computer, so collaborators stop collaborating and jump back to the original repository that you've been working on by yourself. And I'll just edit the README file since I know everyone will have that. So I'll run git status. And there's nothing, I'm in a clean state. If I look at README, we can see that this was the README file that we originally had. This is an edit from GitHub, whatever. And so how do we create a branch? There's two ways we create branches. The way I like to do it is run a command called git checkout -b. And remember, checkout is a way to pick up your head and move it somewhere else, right? So I'm picking up my head using checkout and moving it to a branch using -b. And I'm going to say this branch, instead of by default branches are named master, I'm going to give this branch a name. So this name is going to be called fix GitHub link something, right? So that's what I'm doing. If you look around the internet, there's a command called git branch, and you can create a branch that way. What I like about using git checkout -b is it does two things at once. It'll create the branch and then switch you over to the branch. Because for me, if I'm making a branch, that's what I'm doing. I'm making a branch and I want to switch over. So it saves me one step. But I'll show you how to jump back and forth right now. So if I look at git status, it's going to say, instead of on branch master, it's going to say I'm on branch fix GitHub link, right? If I want to jump back to master, I can say git checkout master. So I'm picking up my head, and instead of fix GitHub link, I'm moving it to where master is. And if I look at git status, it's going to say on branch master, nothing to commit, working directory clean. Right? So that's how you jump back and forth between branches. When I'm working with branches and working with GitHub and all of that, there is a version of gitlog that I like to use. So I showed you gitlog one line last week. And that just gives you a one-line representation of everything that's going on. There's a few other flags that I use. And I'll put this on the Etherpad. So it's decorate, graph, and let me just put that in there. In a way, I've sort of typed this so many times, I've kind of forgot what all of those flags mean. But I'll show you what the output looks like. Oh, I typed that wrong. C-O-R-A-T-E. All right, so don't use a version on the Etherpad right now because that was typed wrong. And let me fix that. There we go. So it's on line 35 on the Etherpad. And this is the output that you get. So I definitely know graph is sort of, it gives you these stars. Where you can see, using those flags, it tells me exactly where everything is. So the last thing we did was we made a merge from collaborator and owner. That's sort of what I did on this file. So let me actually look at README. TXT. Uh-oh. Yeah. So the last thing that happened on README was that there was a conflict, right? So this tells me everything that's going on. So where is my head? Where is master on my local computer? Where is origin on GitHub? And where is this branch? So they're all located in the same spot. And so we can use git checkout, fix GitHub link, so tab complete will work. So that's the reason why when I check out between the two branches, none of my files look different, because they're actually all pointed to the exact same spot. Whoops, sorry. So that's what that line right there is telling me, that master and fix GitHub link, they're all at the same commit hash. Yours will probably say something a little different from mine, but that's how you read this. And if you use a Git GUI, that's sort of one of the nice things about GUIs is this graph representation it's probably always there for you to look at, and you don't have to run a command to see it. So now that if I run status, now that I'm on this branch, let's make a change to it. So just like before, nothing really different in this end. Let's make a change to this file. So the link should be https://. Right. So I'm going to fix this link. So I'm going to save this. And nothing different so far if I run git status, other than it's saying on branch fix GitHub link, everything else is the same. So then say, hey, you made a change, and Git realized that there is this change, so what do? I want to review this change. I can, using git diff. If I'm happy with it, I can say git add, put it to the staging area, and run git commit. Right? So in this case, nothing is really different other than we're on a different branch. But if we look at git log, if we look at git log one line graph decorate all, you can see that now our head is at fix GitHub link, which that makes sense. That's the thing. We were on that branch and we made a change, and that's where we are now. But you can see that now head is different. It's not pointed at master. So master and fix GitHub link are actually at two different points in time. So visually, you can say master was here and use GitHub link is now here. And what that gives us is, if we look at the README, you can see that on GitHub fix, I fixed this link, and then I can check out master and look at the README on master, and you can see it's not fixed. So this is a good way of, especially if you're programming, this is a state that works, and I want to either, one, add a new feature, or two, fix it. Fixing it meaning make it go faster, or you realize that there was a bug and it might take a whole bunch of changes, and you always want to be able to jump back to master just in case, right? So this way I can easily jump back and forth between a state that I know that I'm comfortable with and a working state that I kind of want to keep separate, and I can always jump back and forth between those states. So that's what branches gives us. It gives us like multiple, you can think of as like scratch paper. Branches are, they don't really mean much in reality. There's just a series of commits. And so you can work on something, you can prototype something out. If it works, it works. If it doesn't, you can just go back to master, and it's as if all of that stuff never happened before. Right? So now you don't have to worry about, hey, I'm committing straight to master, and like now this doesn't work, and I have to run git log and find the commit, and then roll back all those commits, or run a reset or something, right? So using branches, it will just be like, oh, I did all this, it didn't work. That's fine. Let's just go back to master and just pretend it never happened. Right? You don't have to use the commit hashes to start reverting changes. Right. So there is a way where you can so now let's say I'm happy with this, right? And I told you master is a place where if you're happy, that's where everything should be. And so if we go back to the image, we want a way of saying, hey, I made this one commit, let's actually merge this back to master, right? So the command is going to be called a merge. So we can merge things in our local computer. So I'm going to do this once, and I'll have everyone for practice create another branch. So trying to remember the order of merge. I believe you have to go to master and specify which branch you want to merge. So I'm going to try that. So the command is git merge, and then the branch you want to merge into. So fix GitHub link. Yes. And the reason why you have to go to master before you perform a merge is this is sort of a very common thing with GitHub, is that you can't really force your changes on anything. Changes have to be incorporated, meaning they essentially have to be pulled, or you have to know what you're bringing in. Someone can't force something into you. That's sort of speaks to how Git is useful as a collaboration tool. So I can run git merge and specify the branch to merge. And now if I look at the README file, it merged in those changes, right? So it brought those changes from that branch and just brought it in with me. And it does what's called a fast forward, meaning all I did was take this and plop it here. And so from C3 to C4 is a fast forward. That's what that fast forward phrase means. So let's say I created 4, 5, 6, like I made a bunch of edits. If I did a merge, then all I'm saying, I'm taking 4, 5, and 6, and I'm tacking it on to master. And so master is now fast forwarded from C3 to C6. So that's what fast forward is. And when you perform a merge, a simple merge like that, you'll see that phrase when you're doing merges. It's just doing a fast forward. And now, if you're working on your local computer, you want to test something out, and this may or may not work. And when it does work, then you'll bring it into master. And now, since you're happy with master, you can then sync this up with GitHub. So git push origin master will then take those changes and bring it up to GitHub, right? So when I'm working from master, that's everything that we've been working on thus far. Push pull with GitHub, and adding things to the staging area, making commits. That part should be nothing new. The only new part that I've just added was now you have this thing called a branch, and this branch is really like a temporary spot for you to make changes, and that you can throw away if you want, or you can incorporate them if it works out. So it gives you a nice safe space to do work without creating a whole bunch of random commits that you don't really mean to have. And it'll just keep your history a little cleaner, but it also gives you the peace of mind that hey, I showed you last week you can use git reset for your cat jumping on your computer. But let's say you go on vacation and your cat has a whole week of jumping on your computer. This gives you a really safe space. If you're working in a branch, you can just go back to master. That's the place that worked. All right. So if I go back to GitHub and I refresh, so all I did was change what the link points to. So nothing visually should change, but hopefully this link now works. And the link works, right? So I made a branch. That branch fixed something. I incorporated it into master. And then since I'm happy with master, I can push that up to GitHub. Right? And you can see that from Git's point of view, there's a button called branch. It really didn't know anything about that branch that you made, right? You had a nice safe working spot. No one really knew about it. That's fine. And if you look at the commits, you'll see the commit that you made, that fast forward. It is recorded because you merged it into master. So that's how you perform merges locally. So the next, and then if you want to look at your branches, git branch -a for all will list all the branches that you have. Star and the color-coded green just represents where you are currently. And this remote origin should mimic everything you have on your computer. That just points to what GitHub sees. And then everything else in white, those are just branches that you have on your computer that you've created. And you can create as many as you want. And now that I've created this branch and I've merged it, I really don't need this anymore. I can run git branch -d and give it the branch name, and that's how I'll delete the branch. Right? So the first exercise, I guess, is everyone create a branch. And in this branch, edit a file, and then stop right there. Don't actually perform the merge on your local computer. So, 1, create a branch on your computer. So branch, you can do this by using git branch and branch, whoops. Followed by git checkout branch name, or you can git checkout -b branch name. All right, so you can create branches in those two ways and move to it. So you're going to create a branch on your computer. You're going to go to your new branch, make a change, commit this, right? And don't merge it. Okay? And right after we do that, I'm going to show you one more how you can do a merge on GitHub, and then that'll be our first break.
I have a question. If you go back to the whiteboard, the diagram.
The diagram. Oops, sorry.
So if you like the.
Sorry. Let me just make it on the side so people don't see this. Yep.
I get rid of, okay.
Oops, sorry. Yep.
So if you make several, commits in a branch, and if you merge it back to the master, where each commit be incorporated, okay, so you can actually go back. I can go here.
Yeah. So the question was, if I made a whole series of commits and I merge it to master, are those commits actually part of master? Yeah. You don't go straight from C3 to C20 when you do a merge. You have everything in between, which is why I said last week, one of the mantras in Git is just commit frequently. Every time you make a commit, that represents a point in time that you can always go back to. And essentially, unless you create a branch and delete it and never do anything with it, you can always go back to it. So one of the questions I've gotten was, can you delete the master branch? Yes, you can totally delete the master branch, but I believe you need to have another branch already, and you can't just use Git completely without a branch. You probably could for some weird reason, but it's not advised. Oh, I should probably have the Etherpad up so I know that UC Davis is ready. right, cool. Were there any like common questions that I should address publicly for recording sake? Do you know, or I don't know what potential difficulties people have, or conceptually, or technically, or technical problems. I don't know. Oh, no. Other than can you delete master? But yeah, I sort of addressed that. All right, cool. So one of the main reasons I think, I'm pretty sure I've read this somewhere, why is GitHub so popular? It's almost ubiquitous. It's because GitHub has a system called issues, an issue tracking system, and I'll show you something called progress right away. But issues are really cool because I use this actually for project management now. If you look at one of my repositories. So anytime I'm at a meeting, and this is a meeting, let me just open up a repository. Oh, geez, I guess I haven't made an update in a while. So if I look at issues, so if I'm at a meeting with my boss and they're like, hey, these are some to-do lists that we need for this project, what I end up doing is I create an issue. Let's say I create an issue and I just type in here, what is this thing I need to do? And typically for each item of a to-do list, I create a separate issue. Right? So this way you don't have to, rely on a notebook that you carry around. You can have very concrete goals, and those goals will be documented in GitHub. And that's what the issue tracker is used for. For more common things, you can use the issue tracker to submit bug reports. But if this is your own project, I totally just use this for project management, and just so I have a to-do list of things that should be done. And this exists on systems like GitHub, Bitbucket, GitLab, any of these online Git viewing systems. They all have that. All right. And what's cool about these issues is, let's say you have a collaborator that you don't want to add as a collaborator for your project, but because they have a GitHub account, they can file an issue. You can, talk and discuss in here, and you can have a conversation, right? So let's say even if this is a person who doesn't know how to code and wants you to implement something, you can have a whole running dialogue of what needs to be done here that's not your email inbox, right? And so this way, all the conversation regarding that thing is all in one place, and you don't have to search for like, oh yeah, or forget like later on, like, oh yeah, you missed this part of the conversation because someone changed the subject thread and now the whole conversation isn't there anymore. So this keeps a very linear conversation. And what's also cool is you'll see that all these issues, and as well as pull requests, they'll have a number next to it. And you can cross-reference these things. So I can say number like 72, and this is probably not going to be good for me. Actually, let's not do it on a real project. So I'm going to create a new issue. I'm going to say test issue. Right, so let's create two of them. I just created a test issue. I can create another issue. Some stuff, and they have like emojis and stuff that you can use as well. But you can use the hash, and you can reference issue. So I am making a reference to number 1, for example. And you can submit the issue. And these references, what's nice is it's kind of bi-directional. So if I'm in issue 2, I can see what issue I'm referencing. And if I click it in GitHub and all of these other systems, bring me to issue 1. And I can have this whole conversation either continue there or something else. And what's nice is when I made that reference, it tells me there was a reference here. So I can actually go back to reference to issue 2. So it is bi-directional, which is something that email doesn't even provide you, really. And what's cool about these issues is that they're regular website URLs. So even if someone is not affiliated with GitHub, because GitHub is completely public, someone else you can just give them this link and they can follow the conversation without having an account or logging in. So that's one of the cool things about GitHub. So now, what did you guys do? So git checkout, I should have done this, -b, let's say another problem, another fix. This is what we all should have done. Create a branch, move to it, make a change. I don't think we're going to have etc. I think that's the extent of what we're going to do. So I'll delete that line. That'll be my change. So I'll add, I'll commit. No, etc. Right? And so this is where we all are. So look at git log -- one line -- decorate -- graph all. I actually aliased that, but I'm just typing it out for you guys. You can see I'm on a branch. That's where head is. It's not exactly where master is, right? And so what we can do is we can run git push, right? Remember git push, the first command is where we're pushing to, so origin. Nothing fancy there. But the second parameter was what we're pushing to. This entire time we've been saying master. But we've created a branch. We don't have to just push master. We're in this another fix. So let's push up another fix. Okay? And so this way we're letting GitHub keep track of all of our temporary work, for example. Right? And all of this stuff is exactly the same text that you would have typed, would have been shown if you did git push origin master. The only thing different is going to say, hey, there's a new branch and it's another fix. That's really the only thing that would be different in the output. And so now, if you go to GitHub, if you refresh it, nothing's going to look different other than your branches now went from 1 to 2, right? And it knows that there is a branch because you explicitly pushed up a branch. And so now we can, just like using git checkout, we can use GitHub's version of quote-unquote checking out by clicking on master to look at the master, where master was, and clicking on another fix to look at what another fix was. So I've opened them in new tabs. So this is master, the etc. is still there. And this is another branch, so you can see which branch you're on. You can toggle between them here. You can see the etc. is gone, right? So GitHub is now keeping track of everything on our local computer. If we run the git log command, we also see that now origin master fix is now here as well, right? So origin master is here. That's where our local master is. Origin, another fix is there. That's exactly where we are, right? And this new thing popped up because we explicitly said, hey, push up this this another fix branch. And I'm typing this in the command line, and it looks a little clunky, maybe. If you've seen it enough times, it won't be too bad. But if you're in a GUI, again, this will all show up in a nice, you'll see nicer circles and nicer labels. But essentially, the information provided will look exactly the same. And so how do you perform a merge on GitHub? Or why would you even want to perform a merge on GitHub? Is because GitHub has this numbering system that you can refer to things. Now your merges can actually, resolve or fix issues that you have. Right? So now you have an issue, you have a problem. You created a branch that solved that problem, and now you can say using GitHub that this branch solved that problem, right? And you can use the issuing system to start cross-referencing everything. Like, what was the code base that you added to fix this? You can go see. And so let me go back to show you how I got to this page. So this is the main page, and I clicked on the branches button on the top. And that's how I got here. And just like the same thing with merges, you can't force a merge on someone. So you can't force your code on something in Git. Changes have to be incorporated. So that's why they're called pull requests. So remember, pulling is taking something and bringing it to you, just like how we said git pull origin master. We're taking the code from GitHub and bringing it to our local computer. So you're essentially saying, hey, I'm going to tell you're going to be the master branch, and you're going to say, hey, I'm going to ask the master branch to pull in this code. And so that's what new pull request does. So we're going to click this, and it's going to say, do a pull request. In this case, it's essentially saying we're performing a merge. In GitHub and all of these other systems is going to see if there's any conflicts. So just like how you dealt with conflicts earlier, if there is a conflict, it'll let you know, and you won't actually be able to perform this merge. But in this case, this was a simple fix, and we're not having a bunch of collisions. So this is going to say able to merge, right? And so the way we read this here is there's a base called master, and we're comparing it to another fix. So another fix is going into master, right? And down here, you can say took out, etc. bullet because not going to be able to cover it, right? So I'm not going to be able to cover it. So you can write your detailed description. One, if you're working by yourself, the description on the top probably would be enough. But if you're collaborating, people want to know, like, what is this change? Why did you do it? Right? So you can be a little bit more verbose here. This is a regular mark. You can do markdown stuff here. So bullet 2, right? And you can have GitHub sort of preview what you did, right? So before you actually perform this, you can preview what you're typing. And then down here, it will just show you the diff. So git diff, it just runs this and prints out the difference down here. So it's going to say, hey, there's only one commit here within one file. If you have multiple files, you can see them as well. And it'll just diff them for you. And you can see that we removed this etc. and we replaced it with a blank line. That's what we did. And so I like doing merges even like this, even if it's my own project, because this gives me one last chance to see what I've done. So I've had multiple chances to see my changes, right? I can, run git diff on the command line and see my changes there. And then I'll push that branch up to GitHub. And now this is another time where I get to see, hey, are all those changes that I just made actually what I want, right? So I send myself pull requests all the time. And you can do references. So let's reference issue 2 and issue 1, right? And there's a shortcut for, there's some keywords. You can say fixes number 1. So let's say issue 1 is, this is a series of commits that fixes number 1. So there are certain words that you can Google. But essentially, when I say something like fixes number 1, when this branch gets merged, number 1, the issue automatically gets closed, and I'll show you that. So when we're done, it can say create pull request, and we're going to create the pull request. If you're working by yourself, you are your own contributor, so you can automatically merge this, right? If you're working with other people, you might not see this because that's someone else's project. You can't, again, I'm not a collaborator for this project. I shouldn't be able to just say all the code I write goes in. But if you added someone as a collaborator, they'll see this. And the big rule of thumb is if you have a collaborator, you don't ever push this button if it's your own pull request. Someone else does it. Meaning there's a whole other series of conversations that you can have, and this is part of the code review process. But if you're working by yourself, yes, you're going to create the pull request, you're going to merge it, and it's going to ask you one more time to confirm it. And when it's done, it'll be merged. And just like running git branch -d, you can delete it on GitHub. This doesn't delete the version on your local computer, but if you want things clean, you can delete the branch on GitHub. And you can see if I go back to issues, number 1 was closed. And that's because I used a special phrasing called fixes number 1. Right? And that's a very GitHub specific thing. And you can see that there's an opens issue and a closed issue. And issue 1 was closed. And I'll reference it right here. This was merged. Number 3, if I go to number 3, this is everything that happened number 3. So everything will cross-reference each other, which is really why this is really awesome project management. And again, I'm just going to delete this branch because I'm not going to need this anymore. And back home, we can see that it was merged, so the etc. is not there. I'm in the master branch. If I look at the commits, we can see that there was an actually explicit commit saying that there was a merge. So that'll be break. That'll be that for now. We'll come back at 2:20, and then I'm probably going to go through the rest of the examples fairly quickly, just so you guys can see a more non-add someone as a collaborator way to collaborate. So if you have any questions, ask them on the Etherpad. Otherwise, yeah, come back at oh no, not 250, 220. Sorry, 250 would be bad. So I don't know if there's any questions from Davis. Everyone back from Davis. All right, cool. All right, so I have 40 minutes to explain the last part. So not sure how much on actual hands-on practice time we'll have, but hopefully I can at least get through the material. So now we're back to this original image. So think of the top as everything we've done so far, now with branches or something. And I showed you how you can add someone as a direct collaborator to your project. And that has its benefits. But the benefit is it's easy to do, and it's not that much work from the workflow I've shown you guys on how to collaborate. But the downfall is now, unless they're using this pull request system or creating branches and letting you do the merge, it's very easy for your collaborator and even yourself when you're collaborating with other people to make a change and just accept your own changes and not even notify your collaborator what you did. So there's a way for us to fix that, and the way that works is if you try to, for example, at home, use git clone on another repository, make your changes, and do a push, and that person did not add you as a collaborator, your change will be rejected. It won't actually go through, and there'll be a whole series of error messages saying that you don't have permission to do that. And so how do you actually make a change to someone else's project is the last bit of this workshop. I just realized this is probably like a 3-part workshop. I didn't really expect to go this slowly, but hopefully it makes sense, everything I've said so far. So the general gist of this is the bottom half of this figure. And the bottom half of the figure will look exactly the same as the top half of the figure, except the top half will be, the owner, and the bottom half will be a collaborator. And the way this system works, if you're using GitHub, is I'll just mention all the terms now, and then I'll go through it. Sorry, someone just walked in. So I'm going to mention how you collaborate without assigning people explicitly as a collaborator. So mention the terms, and then we'll go through. So what's going to happen is we have let me just make this smaller. These clouds are the cloud, in this case GitHub. And the green text will represent someone who wants to collaborate. And if you want to collaborate with a GitHub project, what you do is there is a button on Git, and I'll show you. It's a term called forking. And what you do when you click fork is you take their version on GitHub and you make a copy to your version on GitHub. So for example, I have 2 accounts, my regular account and my teaching account. And I want to use and I don't add my teaching account as a collaborator. So what the teaching account can do is say, hey, I'm just going to copy your version of GitHub into my own account. So it'll be like /teaching/ it'll be teaching/ Git training, and this was a fork from original /Git training. And the benefit of doing a fork is that now you have a copy that you own. And once you own a copy on GitHub, you can do this push-pull system any way you like. That's nothing different there. So that's what this is representing. Right? So you can think of a fork as really like a clone, but just within GitHub. So you only do a fork once. And once you have something on GitHub, how do you get that version to your computer? You run a git clone. Right? So when you're collaborating with another project on GitHub, you're going to make a fork. So your account has a copy. And then since your account has that copy, you want it on your computer, so you make a clone. And once you have the clone, again, push-pull, nothing different there. Now, how do you actually send a change back to the original repository? Just like how we created branches and we created a pull request, when you push your code or your changes to your version on GitHub, you issue the original repository a pull request. And then they can now collaborate, talk to you about if you have to make any changes, they can accept your pull request, et cetera, and then that's how you would actually do collaboration in GitHub, or collaboration that way. And it's actually a very, very popular model, this forking model. Software Carpentry has hundreds of people, and this is actually the sanest way that you can have hundreds of people making contributions, is that each contribution essentially goes through a pull request. Like, no one can force their own changes. Because of this pull request system, everything gets reviewed. And when you have hundreds of people collaborating, you want things to get reviewed. And this works for small teams as well, even 1 or 2 people. This enforces a review process. And so that's what I'm going to do, or show you guys in the last, I guess now, 30 minutes on how this all works. All right, so let's look at the questions. When you add a collaborator, is a collaboration for a given repo for all repos? No, so collaborations are individual repository specific. So you don't say, hey, I'm going to add you as a collaborator. Now everything I work on, you're a collaborator on. No. The settings button in GitHub is project based. You could have something called teams, where you can have a bunch of collaborators all share a set of repositories, but small steps. You can click around GitHub to find that. All right. So how should I do this now? Okay. All right. So this is my incognito folder, which means this is my teaching repository. So everyone's going to end up pairing up. I'm not sure how much, again, I'm not sure how much actual in practice time you'll have, but hopefully enough of this recording is saved that you can go back and practice. And so just like before, I added myself as a collaborator. So to be a little bit better, let's take that person off. So let's say I never added this person as a collaborator before. Right, and let's go back to our original repositories. All right. And so this was when I was collaborating. So you can see that if I don't know, create a file here and add this file, and commit this file and try to push. I'm going to say an error, right? So you're not collaborating anymore. You can't do that. And so how do I actually make a contribution? I guess the only GitHub reference you can see on who I'm doing is, they'll have a picture here, and if I'm in incognito, I guess that's the only way. Let's see if I can just keep things on the left side and right side, and hopefully the text won't be too bad. All right, so I want to collaborate on this project. How do I do so? I go to the person's project I want to collaborate with, and there's this magical button on the top right corner called fork. And when I click fork, it's going to show me this page saying that I'm forking this repository, and by forking, it's really just making a full copy, all the history included. And now you can see at the top, it's going to say, this is me. This is me as the collaborator, and this is my project. And it references it's coming from this project, but this is my own copy that I own, and not the copy that someone else owns. And so now, since this is a copy that I own, again, same thing as before, I can use this HTTPS link, or you can use SSH here. I can use this HTTPS link, and I can clone that down. So let me make sure I'm not in some bad place. So I also have a folder within my Git folder called forks, and this is all projects where I fork things from. So I have this forks folder. I'll give you guys 2 more seconds to do that. And how do I get something from GitHub down? I run git clone and that HTTPS link or SSH link. And that's it. So now I can go into this. If I look at git remote -v, you'll see that its origin and the link actually is my link. So this is my account, right? So I've cloned down a forked version on GitHub, and that forked version is something I own. And what that means is any change I make, I can push up to GitHub. So this is everything. If you think of it as nothing new from that regard, this is everything you've been working with. You can make your change, do push-pulls however you feel, make branches, and merge your own branches, etc., however you want. So I'm going to show you this in branches because I'm a little bit short on time. I showed you branches, and when you make contributions, you should always make your contributions in branches and not straight on master. Again, because master is the, if you're making contributions, master is the working portion from the very, very original place, the place you made a copy from. So, since I taught you branches, let's make a branch. So git checkout -b collaboration branch. Right. In terms of branch names, I have a link in the Etherpad on Git Flow, and they usually do something like feature / collaboration in the name of the feature. So slashes are okay for branch names. Underscores and dashes are also okay for branch names. But yeah, just so you know, the / actually doesn't really mean anything. Other than, doesn't really mean too much. So create a new branch. So just like what I just showed you, this is nothing different. I can git checkout master, and I can git checkout collaboration branch, right? I can just jump back and forth. This is nothing new from earlier. And so let's make a change. So I'll just create a new file. So also realize that anytime you're making a change with more than yourself, there's always the potential of a merge conflict. So I'm sort of simplifying the cases so we don't have merge conflicts. But realize that once you have an edit made anywhere else, in more than one place, there's always a possibility for merge conflicts. And hopefully what I showed you earlier regarding merge conflicts is enough of a start that you can slowly learn on how different ways to deal with them. So nano, let's create a new file in this case. So collaboration via PR, so txt. So pull requests are very commonly just referred to as PRs. You'll see PR pretty much anytime you're working with somebody who works on a Git repository. So PR is really just stands for pull requests, and pull request is essentially doing a branch merge from one person to another. So let's. This is an awesome change. You should accept this. All right, so let's just create a file. And if we look at this, we have this collaboration via pr.txt. Again, we can check out master. And you'll see that, whoa. Oh yeah, whoops, okay. So when you have a file that's not tracked by Git and you switch between branches, that file that was not tracked will travel with you. So that's why when I jump back to master, this collaboration via pr.txt is still there. What is it called? Collaboration branch. All right, so let's add this file and commit this file. Right. So now that I've actually made that commit, if I go git checkout master, you'll see that the master version doesn't have that collaboration PR text anymore. But the collaboration branch does, right? So when you make a commit and you start switching between branches, that's what's going to happen. The rule of thumb is when you do, I won't show you this, but when you do switch between branches, your working directory does have to be clean to switch branches. You'll find out very quick if you're in the middle of a set of changes and you try to switch back to master, it's not going to let you unless the files that you've asked Git to track are all either committed or there's something called stashing that you can Google, but the phrase to Google is called stashing or git stash. But I won't go over that today. So we have this branch, and remember earlier when I showed you when I removed myself as a collaborator, if I tried to run git push, it wouldn't let me. But now if I say git push origin collaboration, if I run a git push, now it will let me, right? And you'll see that something just changed on GitHub. But before it rejected a change that I wanted to make, but now it let me do that change. If you come back to GitHub, you'll see that when you do a fork from somebody and you push up a branch, GitHub and a lot of these other online web systems, they assume that that branch that you made to a forked repository is a contribution you want to make. So it conveniently adds this compare and pull request button for you. Right? So you should see this, but sometimes I think like if you refresh it enough times or you do something else or you make another commit or something, this will disappear. And so the way you can see this button again is you click the branch tab just like before. And you can click the new pull request button. Just like before how we merged it into master, you can merge it, you can merge it to a forked repository. Right? So if I click this or the other one, I end up in exactly the same place. And this screen really isn't that different from sending yourself a merge request or a pull request. Merge request is a term for GitLab. So if you're using GitLab, you'll see it be referred to as a merge request. So this screen isn't any different from the original sending yourself a pull request, working with branches. We were making a pull request from a branch to master. The only thing that's different is the branch is coming from my repository, and I'm requesting it to go to the master branch of the original repository. So these two things would be different when you are collaborating. All right. So before it was easy, I'm just sending it to myself, in which case the name here would be exactly the same. Again, you could send it to yourself just like before, but GitHub assumes that when you're making a branch to a fork repository, you're actually trying to make what's known as an upstream contribution. So you're trying to contribute back to the place you're getting it from. Right? So when you guys are working in pairs, this first name should be different, and I guess -teaching is my way of trying to convey that. And just like before, you can say collaboration via PR example, and this is when writing these messages is more important than just communicating with yourself. This is someone else that you're contributing to. This could be a very large software project, a large project, a small project, who knows? But this is when, nobody wants to read through code to figure out what you did. So do everyone a favor and write down what you did. So this is, I created a file, new file. to show collaboration using forks and pull requests. That's all I did. I created a new file, and this is what this file does. And when people read this, then when they read the changes or the diffs down here, they have some context on what's going on. And so I'm going to say create the pull request, and that's it. So before, you know that when I was my own collaborator, this thing was already like, hey, do you want to merge this branch and confirm this merge, et cetera, et cetera. But now since I've asked someone else, you can see up here, I am asking my teaching account is asking my main account if he wants to accept this change. And because I'm not in the main account's list of collaborators, I can't automatically, I don't have that magical green button to automatically accept my changes. Right? So that's what a pull request looks like. And so let's look at it from the other end. What does it look like from you as a collaborator, you as like the owner? If you can see, instead of my teaching account now, this is the original ownership account. One, you'll get an email wherever you have your account set up to. You'll get a nice GitHub email. And two, you'll see pull request. There'll be a new number show up. A new number will show up for pull request. And you can see this is pull request number 4, which is really issue and or pull request number 4. Issue or pull request number 4. So issues and pull requests in GitHub and a lot of these systems just follow the same. They're just part of one numbering system. And who is this coming from? This is coming from my teaching account. Right. So earlier when I showed you just yourself working with branches, this was just coming from yourself. But this is now showing pull requests, so it's coming from my teaching account. And I can click on this. And now I see, you know, this is the title that he had, or that I had, not he. And this is the person who's commenting. This is the comment that he made. You can now see that because I own this, I see this button to merge pull requests. But before I merge it, I want to be able to review this. So I can look at the commits. You know, it's only one commit. That's all he did. If you get a pull request and all of a sudden this number is in the 500s, kind of scary. You know, why did this person make 500 like changes? A little weird. Maybe he shouldn't have done that, or he or she should not have done that. But the cool thing is you get to then look at the files changed, and you get a diff. And what's cool about this diff, and what's really nice about how this adds to collaboration is if you hover over the diff, you get this plus sign. And you can actually leave like inline comments like, why is there a line break at the end of this, right? You can comment line by line. And when you go back to the conversation, it'll keep track of that comment you made, but you can also have general comments. So general comments here. Right? So you can make a comment there. And again, this is a conversation that you're having regarding this pull request. Right? So just because someone sent you a pull request doesn't mean you have to accept it. And if they do send it, you know, it would be nice to give them feedback like, hey, this looks great, I'll accept it. Or hey, if you're not happy with it, you can tell them to make changes. Right? And so one of the things that people get really confused about is, okay, I sent this pull request and he told me to make a change. Now what? Do I close this pull request, fix the change, and resubmit it? No. Once you created one pull request and it's in a branch, if you make a push to that branch again, it'll update the pull request. So once you make a pull request, everything will be linked. So let me show you. He said, or by he, I mean me as the original owner, asked, why is there a line break at the end of this? Assuming, let's get rid of this line break. So this person told me to get rid of this line break. And so let's get rid of the line break. And I'll change this file by getting rid of the line break. If I look at Git status, nothing different or nothing surprising here. I've made a change to a file. I can add this file. commit this file saying I removed a line break. And I can push to origin and the collaboration branch. So this is what I just did before, right before I clicked the buttons to perform the pull request. And so this is exactly what I did before. Because I've created a pull request once, that change will trickle through, I hope. Wait. Uh-oh. Oh, yeah, I think. What's going on? I wonder if this is my computer being slow, but as I half try to figure out what's going on. But you as a collaborator, you can have access to this conversation as well. So, so just, I showed you the original person commenting. You can comment on this as well. What's going on? Fail? Oh, that failed. No wonder why. Okay. Oh, okay. That's the teaching. There we go. All right. So I successfully made a change to my copy, and that trickled down all the way to the pull request. So you can see that I'm in my account looking at this pull request, and commit went from 1 to 2. When you make a change to a line that someone commented on, GitHub will automatically collapse it, assuming that that was a comment that you fixed, so it doesn't need to show you anymore. And your commit will show up here. So this is, I removed the line break. You can look at the commits, and I removed the original collaboration, and I removed the line break. And if you look at the files changed, I've removed that line break. All right. So when you make a pull request and you make it, and someone asks you to make a change, you don't have to close it and resubmit it with the proper changes. Just send it. Just keep sending it to your own fork. And so now I'm happy. I can click merge, and everything will be merged. And now that's merged. And so me as the original collaborator, since I merged it, and this was a merge going from my collaborator's collaboration branch to my master branch, I can now pull from the master branch, and you'll see that the collaboration via PR text is now on the owner's computer. So this, let me show you the figure. So what did I do? I made a copy. The collaborator made a copy. He did his changes. He submitted changes, and now I updated my changes, right? And so the last, hopefully I can get through this, there's one more like nuanced thing that happens here. What if the original owner now makes a change and updates GitHub, right? How do you as a collaborator now get that update? Originally, it was easy. We made a fork, and all the newest changes came down with it. The way you don't want to do it is delete it and refork it, right? Like that's kind of the whole reason why people are listening to me, is to avoid the whole let's delete this and start over nonsense. So just like how I mentioned, remote is anything other than where you type git init. This entire time I'm saying the place on GitHub that you own is a remote, and by default that remote is called origin. What I can do as a collaborator is now add this person's GitHub account as an origin. By default, you'll see in tutorials, this will be called Upstream. And what you can do is you can pull the code from this person's Upstream account to your local computer, right? You're not making a change to his account, so you're allowed to make a pull. You can pull down the code, right? Just like you can clone his repository, you just can't push back up. You can pull down his changes, update your local computer, and then once your local computer is in sync here, you can push your changes locally to your version on GitHub, right?
if you are not a collaborator anymore and for it,
Yeah, so you can make a pull even if you're not a collaborator anymore. And why that works is because, well, you don't have push access anymore, but you can still have pull access. Right? So pulling is okay. This is GitHub. Everything's public. Like, you can get whatever you want. I'm just going to put limitations on who can change what and when. So I'm going to pause for a little bit to make sure that at least the overall concept makes sense before I show this. So Etherpad, if you need me to go over generally what's going on.
If you can pull directly from the master to your local computer, what's the point of using fork?
Okay, so the question was, if I can pull directly from master to my local computer, what's the point of using a fork? You don't have to make a fork, but if you never made this fork to begin with, you're going to have to go to click new repository, create the repository, get the remote, and set the whole remote up. Clicking fork just does that all for you, right? And it has the same name. And the benefit is if you click fork, you can link back to where you got it from. If you click a new repository, it's going to be a brand new repository. You won't have that nice that footnote saying that where you got a fork from. Yeah. All right, so I'm going to show this entire process. So now my local computer is updated. I mean, me as the original owner, I incorporated your changes. So I'm going to make another change. So I'm going to say nano owner collaboration. Right. Change. So I'm an owner. I'm making a change. You need to pull from my GitHub repo to your local computer in order to make additional contributions. I hope I spelled that right. If I didn't, someone send me a pull request, right? So I'm the owner. I'm making a change. This part should be very tedious now, where you made a change. You have to add this. You have to commit this. Right? And I'm pushing this. I'm pushing that up to master, right? So me as an owner, I could make this a separate branch and merge the branch and all of that stuff, but let's say I'm just putting this up straight to master. And so on the GitHub side, there's this owner collaboration, right? So that's the owner's view. And if I look at the collaborator side, right, I don't have that file. How do I get that file? Like, you made this change, now I want to make additional changes, and just like when you make two changes in two different places, you can't make a push unless you pull down and everything's in sync, right? So that's, if you try to make a change here, that's the problem you're going to have. And so, how do I do this? So let's look at git remote-v. Let me just make this big. Git remote-v. So you see origin, this is pointed to my account as the collaborator. So what I have to do is now I have to go to the owner's page, find his link, and then I say git remote add. So before we wrote origin, and now we're going to say something like Upstream, right? Again, this is a name that you can make up. Like, it could be pizza. But at least when you're working in this kind of model, a lot of the tutorials you'll see online will use the phrase Upstream. Right? when you start collaborating, when you add more and more people, a convention is you start adding their username as a remote, right? Just so you aren't like freaking out. But chances are this is as far as you're going to go in your Git careers for the next like year or so. I would imagine it took me about like a year and a half to fully like understand all the internal workings of what's going on. So don't fret too much about this being overly complicated. So git remote add upstream, and then this is the upstream link. So you can see that this is the original owner, not my teaching repository. Now if we look at remote-v, we can now see we have two remotes. There's an origin, and then there's an upstream, right? And so let me go back to git checkout master, right? So if I look at status, I'm on master, and everything looks good. This is also one of the reasons why I like to be really explicit, because you sometimes don't know where you are and you just type things by muscle memory. So always type git status everywhere you go. So now I can say git pull. Before this entire time I wrote origin, but now we're saying we're going to pull from upstream, right? And the thing we're pulling from upstream is master. Now you can see that the collaboration via PR, that was the accepted pull request that the owner made, and then the owner collaboration that he made and he pushed up to his own repository is now on my local computer. And just to finish off this entire triangle of things going on, we can say git push origin master, and now our own repository will be updated. Right? And so that's what you do when you start collaborating with people who won't give you collaboration rights. You know, sometimes you just need someone else's code. You probably don't even, let's say you just want to extend someone's code and you don't plan to collaborate back. You know, you can do that as well. Maybe it's called a fork because the project has a potential to fork, and these started with the same base source code, and now things are diverging because you are implementing features that the other person doesn't have any use for, and you don't want to, you know, it just makes sometimes for smaller projects or whatever, it just makes maintaining the project a lot easier. But yeah, so that's the entire spiel. That the last part that we did sort of rounds out the whole entire collaboration process. How you collaborate, you can work on master directly. I did it with branches. The benefit of using branches is it prevents fewer merge conflicts. If you keep doing everything on master, there's a very big potential that there's going to be a lot of merge conflicts. So more branches, better. But yeah, so that is my spiel for Git. I don't know if anyone has any other pressing questions, because it is also almost 3 o'clock. So. All right, no questions. I guess that seems like everything. I don't know. Maybe there could be potentially sometime down the line as like an even more advanced thing on Git for working with branches, but this definitely is more than enough information for people to start using Git. And chances are for the first 6 months to a year, it will be everything from day one. And that's probably the world you'll live in for the first year, just so you get used to all of this. Yep, so I think I'm done. So I guess the YouTube stream can end and all other streams can end. And thanks for listening.